So in section 10.3, we're going to start bridging the gap between solving system equations by hand and solving them by computers. And kind of the first step in doing that is to move from your system of equations like this to something that you can input easily into your calculator, which is called an augmented matrix. Now, the augmented matrix in this case is just going to be the coefficients and not the variables. So for the first equation, it'd be negative 1, 0, 1, negative 1. In the second equation, 0, 3, negative 2, and 7. And finally, 1, negative 1, 3, and 3. So something like that. That's kind of nice, and this is called, like I said, an augmented matrix. So, augmented matrix. Because the positions kind of imply the coefficients, or imply that this is the coefficient of a particular variable, we don't have to write down the variables, and this is something you can easily put into your calculator. Now, there's one thing that you should know about matrices, and that is the dimensions of the matrix. The dimensions of the matrix are always written in the same order. And it's usually at this point I make some kind of a joke about my corporate sponsor is RC Cola. So it's over 100 years old. I don't think you can find it very easily anymore. Somebody got me once from a vending machine in East Lansing. In any case, the importance here is that it's our mnemonic for remembering row, then column. When you talk about matrices and their dimensions, it's always the number of rows by the number of columns. So the dimensions of this matrix would be what? Good. 3 by 4. Good. Number of rows, the number of columns. You got to make sure you have that straight. It's going to become particularly important when we start multiplying matrices. So hopefully you're comfortable going back and forth between an augmented matrix and the regular system of equations. It's a nice one-to-one correspondence here. Now, you can manipulate this matrix in ways that we'll practice in a little bit, but you can manipulate it into something called Row-Echelon Form. So let's talk about that for a second. Row-Echelon Form. Row-Echelon Form. Now, like I said, the manipulation of that into Row-Echelon Form takes a lot of work. But let me write down what that system of equations would look like. It'd be 1, 0, negative 1, and 1. 0, 1, negative 7 halves. Excuse me, not negative 7 halves, negative 2/3. My bad. And then 7/3. And finally, 0, 0, 1, and 13 over 10. Now, what I want you to get out of this is what row echelon form looks like. You've got zeros below this main kind of diagonal here. And that makes this a much friendlier system of equations to work with. So if by some magic we were able to put things in row echelon form here, then solving this system of equations wouldn't be too bad. In fact, let's write down what this system of equations would be. So the first one would be x minus z equals 1. Second equation would be y minus 2/3 z equals 7/3. How about the last equation? Good. Z equals 13 over 10. So nice. If we had something like this, could you solve this pretty easily? Sure, because we already know what z equals, right? Z is 13 over 10. Plug that in here, and then you can get y. Plug it in here, and then you can get x. So solving from this point is not too bad. But we can actually go a little bit farther and put things not into row echelon form, but reduced row echelon form. Reduced Row-Echelon Form. So what would that look like? It would look like this: 1, 0, 0, 2.3, 0, 1, 0, 3.2, and 0, 0, 1, and 1.3. So if by some magic you went a little further and were able to put our augmented matrix into this form, now write down what that system equation says. What does that correspond to in terms of x, y's, and z's? Sure. X equals 2.3. Y equals 3.2, and Z equals 1.3, which makes sense because that's what it was over here, right? 13 over 10 is 1.3. Nice. So you've got your solution there if you're able to put things in reduced row echelon form. Sometimes it takes a lot of work, and if all you're interested in doing is solving it, maybe you're better off putting it into row echelon form and then just undoing it here. Kind of depends. Now the difference here is that with reduced row echelon form, all these have to be 1 or 0, and everything off this diagonal other than the right hand side is again 0. So you can have numbers on the right hand side, 1 or 0 on the main diagonal, but 0 everywhere else. So that's reduced row echelon form. It's a pretty handy form to have a matrix in. Let's kind of build off that a little bit. Take a look at problem number 16. 1, 0, negative 7, 0, 0, 1, 3, 0, 0, 0, 0, 0. Oh, excuse me, no, it's not a 0 there, it's a 1, right? It's a 1 right here. Let's see if we can't write down the system of equations that corresponds to this augmented matrix. And even though it's not written, it's kind of understood that this is your right-hand side. So what would the first equation be? Good. X minus 7z equals 0. And then y plus 3z equals 0. How about the last equation? What's that say? It says 0 equals 1, right? There's 0, 0, 0, 0 equals 1. Can you see a problem with that? Yeah, 0 doesn't equal 1. So what that's telling you is that if you put things into reduced row echelon, well, actually row echelon form like this, and had something like this as your last equation, that's an inconsistent system of equations. There's no solution to this system of equations because 0 can't equal 1. So that's it. You know there's a problem there. Yeah, there's no solution. Inconsistent really means that these planes don't intersect in one point. So something else is going on with that system of equations. But you can't get a nice, X, Y, and Z solution there. You'd have to take a look at the original system of equations. There's a couple different possibilities as to the geometry on that. And I think we have a picture in the book, if you let me look for it just a second here. It shows all the different possible, or some of the different possible things that can happen. It should have been in section 10.2. There we go. Right here. So one possible configuration is something like this. Another possible configuration is that a couple of the planes are parallel, and then one might be askew to that. But if you have two parallel planes, again, you're not going to get one solution like you are in a lot of cases. Exactly. So there's three general classes of things that can happen. You can get 1 point, you get no points, or they intersect in such a way that you have an infinite number of points. They're intersecting along a line. And that's going to become an important case towards the end of our work here in this section. Now, I said we're going to try and bridge the gap between the calculator and what we do on paper. So let's do that. And to start that, let's take a look at problem number 22. And we're going to need to enter this into our calculators. So let me help you out with entering that into your calculator. What you're going to want to do is hit the second key, then the X inverse key, and that'll take you to the matrix menu. And from there, we're going to want to edit things. So hit the second key, then X inverse. X inverse is down here. Takes you to the matrix menu. Cursor to the right twice or to the left once to get to the edit menu. So something like this. Press enter there. Yeah. Now you're going to need to type in a 3x4 matrix. I've already got this entered, but you want to type in these entries. A bit loud. Thank you. Now, as you press enter, you enter 1. Hopefully, you're typing in a negative with the minus key or the opposite key on the bottom row of your calculator, not the subtraction key. -5, 2, -3, etc. When you press enter, it'll advance your way through the matrix. You got to enter in all those values, and then we're going to quit. So 10, -3, 1, -20, -1, 3, 1, and 8. So everyone got that entered. Now to stop entering this, to exit here, you press the second key, then the mode key. That'll quit. That gets you out of the entering phase, out of the editing phase. And now if you want, you can take a look back to make sure that you typed in the right matrix. So hit second, then matrix again to bring you back to the matrix menu. And just press enter twice. And that should take you, it should print out what your calculator has stored in matrix A. And that should match what you want here. So are we okay with that? Now what we're going to do is we're going to manipulate this matrix to try and get it in row-echelon form. We're going to go a little bit farther than what the book says. The book says I wanted to be able to take things and, let's see, problem 22, let me get back to that. I think they just asked you to multiply row 2 times row 1 and add it to row 2. So here's that. We're going to take 2 times row 1 and add it to row 2. Well, don't follow this way. There's a lot of commands that your calculator can have that it uses to manipulate matrices. You can swap 2 rows. You can add something to a row. You can multiply a row by something, or you can add a multiple of one row to another row. So there's a lot of possibilities here. It's a pain to do this. So just sit back and relax for a second. Problem 22 asked me to multiply 2 times row 2 times row 2 and add it to, 2 times row 1 and add it to row 2. Here's what it would look like if you were stuck doing it by yourself. You'd take second matrix, you'd have to go over here, and then up to this command, star row add. So what's the form of that command? It's the value, then the matrix, then row 1, and then row 2. So the value would be 2, comma, which is above the 7. Matrix, got to go back to this menu, comma, multiply row 1 and add it to row 2. Wow. A lot of work, and it also requires you to be familiar with the form of this command. So there they all are if you want them. This is why I put program ROWOPS on all your calculators. So let's run program ROWOPS. Everyone's got that matrix in there, right? Yes? We're all good? I want to make sure you're together. It's your chance. All right. So, Maha, you got that matrix entered?
Yeah, but second part.
What second part? This is the matrix you're supposed to have entered. You got that entered? Okay. Ronnie, you good on that? You got that matrix entered? The 3x4 one, yeah. Okay. This is the one that I want entered. That should be in matrix A. So hit program, and then ROWOPS, and then press enter again. What matrix do we want to work with? A. So let's select A. And it shows you the matrix you're going to work with. That's good. So press enter again. And this time we want to do multiply a row by something and then add it to another row. So select 4. And all this program is doing for you is just making the process of, multiply row add a lot simpler for you because you don't have to remember all the forms of these commands. Multiply row, which row are we going to multiply by? Or which row are we going to multiply? 1. Multiply by what? Multiply by 2. And add it to row 2. So type these things in. You should get something like this. And then as soon as I do it, I should get a 0 where that 10 is next. Are you able to get that? What's wrong? What? What's wrong? Did you press program and then enter again? You have to press enter twice. Once you select the program, press enter twice, and that'll start the program running. Type program. Program. Enter and enter again. Okay, now press enter, and then the first operation is this one. So the first operation was multiply row add. So I select 4, multiply row 1 by 2, and add it to row 2. So I'll let you finish that up. Are you... One second here. Okay.
So you do the program. I just hit program.
You didn't select program ROWOPS. You got to select program ROWOPS. That's the one they put on your calculator.
Okay. And then what do you do after that? Because that's what I had the first time.
Press enter.
Okay.
Now select matrix A. So select 1. Press enter again. Now press matrix, or press selection 4.
Enter the matrix right. It's not in A, it's in C though. But it shouldn't affect that, right? And I did row by 1, 2, 2, and it gives me 20.
It's because you don't have a -5 there in the upper left-hand corner. So yeah. Yep, no problem. No problem. Anyone else? Tierney? Did you catch up to where we're at? So you should be right here. Dallas? You know, yeah, I know. It is kind of a problem. I don't there we go. Good job. Thank you. All right, so let's keep going. Now, that's all that problem 22 asked you, but what I want you to do is become familiar with all the different things you can do with this program. So we're going to continue to try and put this matrix into row-echelon form and then reduced row-echelon form. So row-echelon form means I'm going to have zeros here and here. And to do that, I'm first going to switch row 1 with row 3. So is everyone right here in their program? Bilal? Yes? Encho? Are you? Okay. George? You up here? You with? Okay. So we're going to switch these two rows here. So press enter. Which command do you think we want? Row swap. Right. So the first one, and it just tells it. It's just all menu driven. It just makes it a lot friendlier. So we want to select the first row, and we're going to swap it with the third row. So what you should see when I press enter is these two rows interchange. So we want to interchange those two rows. So you're going to press enter to take you to your menu of selections and select the first one, which is row swap. You want to interchange rows 1 and 3. Encho, you want to give me your calculator? I'll make sure you're with us. Okay. So, somehow. All right. Somehow or another you got off track. So let me see if I can't get you back on track. So 4, 1, 2, 2. Okay, I think you're with us now. All right, everyone's here, right? Now, when you work with these matrices, kind of follow the order that I'm using to get the zeros. I want a 0 here. So let's take, what's going to put a 0 here? If I multiply the first row by what and add it to the third row? -5. So let's keep that in mind. We want to do a multiply row add. So you press enter to get back to this menu. Do a multiply row add, so that's 4. Multiply row 1 by -5 and add it to row 3. You should get something like that. Tierney, you have a crestfallen look. Did you not get that?
No, I got it.
Okay, good. All right, that's good. Feel better. Whoops. Because you use the subtraction key to enter -5. You need to use the opposite key down at the bottom here to enter that -5. Yeah, that means the one bummer thing about this program is that if you make a mistake, it's sometimes difficult to recover. What you could do is take your last working matrix, copy it into A, and then start from there. That'd be a kind of a workaround for this. And sometimes there's other workarounds. Let's keep going though. Let's get a 0 where the 13 is. What do I need to get a 0 where the 13 is? Yeah, multiply this by 13 and add it to this one. So let's do that. let's take, so we press enter. That brings us back to this menu. And then multiply row add. So that's 4. Multiply row 2 by 13 and add it to row 3. Wow, kind of a big one there. But that's where we wanted to be. That's exactly where we wanted to be. Now let's think about this last equation. Whoops. That last equation is really negative 73z equals negative 219. I'll tell you what. Let's press enter one more time. Are we still all together on the same page here? Sarah? You with us? Okay. This time I'm just going to multiply a row by a number. So let's select number 3. What row do you think I want to multiply by, or multiply? Third row. Let's multiply by negative 1 divided by 73. And make sure you use the negative on the bottom of your calculator, not the subtraction key. All right. So, wow. That looks pretty cool. What's that last equation telling us? Z equals 3. And once you know what Z is, you can go back and find Y, and then you can go back there and find X. So the problem pretty much unravels itself once you get these 3 things to be 0. Now, just for the practice, let's continue to make all these things 0 and put it in reduced row echelon form. So if you're going to do that, the next thing I'm going to do is I'm going to get a 0 right here. So maybe you can start helping me out. What would I do to get a 0 here? Yeah, so multiply the third row by 5 and add it to the second row. So that's going to be a multiply row add. So that's fourth command, multiply row 3 by 5 and add it to row 2. Okay. Yeah. Isn't that cool? So we can see 2 of our solutions right now. We got y equals 1 and z equals 3. The next 0 I want to get is right here, where the 1 is. So what do I do to get the 1? Get rid of the 1 here? Yeah, row 3 by negative 1. So, fourth selection, multiply row 3 by negative 1, add it to row 1, and we're getting closer. I mean, certainly you could solve it at this point, but I'm trying to build up skills and comfort with you in this program. Almost done. 2 more steps. I need to get rid of the 3 here. Wow, you got to do that in sync. You guys are practicing outside of class, I think. All right. So multiply row add. So it's a 4 selection. Multiply row 2 by negative 3. Add it to row 1. That's almost in reduced row echelon form. There's one thing left I got to fix. Vishal? Yeah, the negative 1. So I can just multiply this equation by negative 1. So go back up to your menu and do that. Demetrius? There's no undo. Sorry, you can't really undo very easy. If you type in something wrong, there's a couple. Well, there's one possible solution is, you look at your last matrix, and then you store that in. Yeah, sorry. There's only so much time that I have to do on these things. So the last thing would be multiply row 1 by negative 1, and bam, there it is. There's your solution. X is negative 2, Y is 1, and Z is 3. So cool. Now, a lot of this was just really to get you to practice with this program so that you can do it at home. We are going to do other things with this, but it's handy. It's just nice not to have to type in these commands one at a time. And oh man, it's so. You know, it might even blow up. I'm not sure. It might just blow up. So I have to look back at that because I think it did have some problems with that. Any questions on problem 22, the extended version, Encho? Yeah, you can do it by hand. Yeah. Well, I mean, the reason I gave you this program is because to do it by hand, you got to sit there and go, okay, 2 times row 1 plus row 2. So it'd be negative 10, 4, negative 6, 6, added to 10, negative 3, 1, and negative 20. And that gives me 0, 1, negative 5, and negative 14. So then you'd write down your next matrix, which would look like this. Negative 5, 2, negative 3, 3, 0, 1, negative 5, negative 14, negative 1, 3, 1, and 8. And then you got to do it again. There's 2 problems. One, it's really slow. Does anyone know what the other problem is? It's easy to make an arithmetic mistake. And that just kills you. It's really unfortunate to see people go and do a lot of work, and oh, way back in step 2, you made a little typo, you forgot a negative, and then, oh, man, you already experienced what it's like to miss a negative. It screws you up, and then you got to start all over again. So, wow, at that point, you do one of these, you take your professor's name in vain a few times, and you're like, why do I got to learn this? So no, I encourage you to use the program. It's up to you, though. Yes? Yes, we are. Yeah, no, it's all right. So all right, we are going to do another one of them. We're going to jump up to problem number 38. Yes? So, yeah, good question. On the test, I want you to write down something like this, like row swap 1 and 3, 3 times row 1 added row 2, or 1/10 of, or 1/110 times row 2, that kind of thing. Just a few things to let me know that you're actually doing these steps. And we'll do this as we go through problem number 38. Let me start by writing down problem number 38 for you. In fact, I'll let you take a quick peek at it, and then we'll write down the augmented matrix and put that into our calculators. Yes, I do. Just come on up and exchange one. So there's problem 38. But what we want to do is we want to put in the augmented matrix. So that's going to look like this. 38. $10, negative 20, and 60. 15, 20, 30, negative 25, negative 5, 30, negative 10, and 45. Now, one annoying kind of thing is that to enter this matrix, you need to completely exit the program. So here's kind of the fun part. You exit the program, and you get a little note from me. See ya. All right. All right, so we got to exit the program to enter in a new matrix. Let's do that. Now, I'm not sure. Yeah. See, I was clever when I did the morning show. I saved it in matrix B. You can type it in matrix A or B, but I've already entered this matrix. Again, to enter your matrix, you hit the second key, then the matrix key. over to Edit, and then you press Enter. You type in the dimensions of your matrix, which is a 3 by 4, and then type in the exact values. George? How do I do what? Well, are you in program ROWOPS still? Press Enter and then the number 7. That should get you out of the program. So I've got this matrix in matrix B. You can have yours in A. You can have it in any place that you want. It's up to you. But I choose, something simple, A through F. Does everyone have the matrix entered? All right, a couple people. Dharma, got it entered? Okay. All right. Ronnie? All right. When you're done editing, press the second key, then the mode key to quit, to exit out of that. You can then type your matrix by hitting second and then matrix, and then choosing whichever matrix you want to type out. Press enter a couple times, and you should see the value that you entered. Hopefully they match what you have here. If they don't, go back and edit this. Okay, so we all set? Everyone got that in? Hit the program key. Select program ROWOPS. So type the number or just press enter if it's number 1. Press enter again. That should initiate the program. And then select whatever matrix that you stored it in. I stored mine in B. You might have stored yours in A. That's fine. Select whichever one you stored it in. So it should give you that. So run program ROWOPS. Press program. Select ROWOPS. Press enter. Press enter again. And then select your matrix. Should be probably matrix A, I would assume, right? So then just type a 1, and it brings you here. Now, as far as getting zeros in a matrix is concerned, to put it in reduced row or to put it in row-echelon form, you want to do it in this order first. So get zeros in this order. So the first one you want to get to be a 0, I want that one first, second, and then third. So that's the order of operations in terms of getting zeros and putting this into row-echelon form. Now I'm going to take kind of a different path to doing this than you could. There's a few ways you could do this, but I'm going to start by swapping the first and third row, because I noticed that both of these numbers, 10 and 15, are nice multiples of -5. So that's where I'm going to start. Row swap 1 and 3. And as far as what I would write down on a test, row swap 1 and 3. Okay. Let's keep going. I want to get zeros in those places I mentioned, starting out with the 15 here. What am I going to do to make that 15 disappear? Make it a 0. -3 or 3? Which one? Just 3. So you're going to multiply this row by 3 and add it to this one. So multiply row 1 by 3 and add it to row 2. So you could write it like this. 3 times row 1 plus row 2. Okay. let's get a 0 here. Perfect. Multiply the first row by 2 and add it to row 3. So go back here, multiply row 1 by 2, add it to 3. So 2 times row 1 added to row 3. All right, that's looking better. Now I want to get rid of the 70 here. Now my original solution when I was thinking about this problem at home was to multiply this by 11 and then multiply this by -7, but there's a better solution. Let's take a look at this second row here. What if I divided everything by 110? That'd be pretty nice, right? So let's do that. Select the third option. Multiply row 2 by 1 divided by 110. So multiplying by 1 over 110 gives you this, which is nice. Yeah, y equals 1. You got your solution right there. Is everyone still with me? Okay. Why don't you sidle up next to somebody and no, you just work off of one calculator. Just share the calculators there. All right. So we're right here, right? I want to get a 0 where that 70 is. What can I do to get a 0 here? So -70 times this row added to this row. So we're going to do a multiply row add. So press enter. Select option 4. Multiply row 2 by -70 and add it to row 3. Wow. That's looking better. Let's keep track of that. So that's 1 over 110 times row 2. And then underneath that, we should write -70 times row 2 added to row 3. We're pretty much kind of at the point where we can solve this, right? If you wanted to, you could divide everything by -40, make it pretty obvious. So multiply row 3. So option 3 gives you multiply row add, or excuse me, multiply row by -1 divided by 40, and bam. So 2 of your solutions are right there. Z is -2, Y is 1. And now we're not going to go to the extreme of putting this in reduced row echelon form. And we can pretty much solve it from here. The last thing we need to do is work with -5x plus 30y minus 10z equals 45. I already know that y equals 1, z equals -2. So let's plug those in. That's -5x plus 30 plus 10 equals 45. So -5x equals 5. I get x is -1. Oh, wait. My bad. -2 times that should be plus 20. So it'd be +1. There you go. So your overall solution is 1, 1, -2. The important part, though, is to get comfortable with these row manipulations. You can do it by hand. Yeah. See, the thing is, these kind of operations are going to be instrumental in trying to find the inverse matrix 2 sections from now. So right now, we're just worried about solving a system of equations, but they help you solving and finding an inverse matrix too. So Yeah, this is stuff that I would definitely practice. Yes, sir.
Is that always where you want zeros?
Those particular ones, yes. I mean, once you get good at this, you can kind of manipulate and understand other ways to work these. But I would suggest that until you're really comfortable and know this intimately, that you start by getting zeros here, here, and here. Can you do it other ways? Absolutely. There's a lot of other ways. I think that's the safest way to do things. You know, one of the problems, we didn't really see it here, but if you do things in a different order, then it kind of screws things up. So, let's see, matrix A. For instance, if I got a 0 here and then tried to get a 0, what if I tried to get a 0 here? You know, second. I could get a 0 here by adding them, but then it makes this thing something other than 0. So, yeah, the order there is important, and if you practice with it, you'd see that. Any other questions on this one? Too many to ask? Go ahead. Ask one then. Start by asking one. That's a great question. I wanted to put something up here in this diagonal that would help me get zeros below here, so that it's something I can easily multiply by and get a 0 below. Now to start with, if I wanted to use this one to get a 0 here, what do you multiply 10 by to get negative 15? I mean, if you're smart enough, you can say negative 1.5, great. But if not, it'd be nice to give yourself something easier in this position so that you can multiply by a nice integer and cancel things out. And that, for me, was why I put the negative 5 up here. Because negative 5 times 2 canceled out the 10. Negative 5 times 3 canceled out the 15. So that's what my choice was. Another approach to that would be if you divide this whole equation by 10. Then you have a 1 here, and then you can say, okay, negative 15 times the first row, that would give me a 0 here. So there's a couple different ways we could have done this. I just chose one. Okay. So what you want in these positions, here and here in particularly, is numbers that can help you get zeros for the ones below it. Yeah, the number 1 or negative 1, or that this can help to give you zeros here and here. So that these numbers are multiples of that one. You can multiply row 3 by negative 1/5 and then swap it. There's a lot of ways you can do this. There's more ways than we could even discuss. But it's just going to take a little practice. But do things in this order. Get zeros here, here, and here. You should be in good shape. Here's another question.
Yeah, just, I don't know if you answered it, but you know how you have to get the 15 to 1? Could you, like, first step, could you just multiply the row by 1 over 15 instead of, like...
Well, in this case, 1 over 15 would give you fractions here and here. So it's not as easy as, say, multiplying this by negative 1 over 5 or multiplying this by 1 over 10.
So it's not just about getting it to 1, but, like, the whole row.
Yeah, well, you need zeros in these key positions. That's what you need to get it in reduced row echelon form. Or row echelon form. I always want to say reduced row echelon form. Okay. Now, getting it in that form is really, really handy. So, let me see here. Let's take a look at problem number 68. And we're going to do two things with problem 68. And both of them are going to require us to input a rather large matrix. So, tell you what, let me put that matrix up for you. The one we're going to enter. So it's going to be 49, negative 27. Actually, I think I've got it stored here. Let me see. Matrix. Yeah, there we go. So this is the matrix that you want to enter. 49, negative 27, 52, 0, negative 145. Somebody other than the usual suspects. What are the dimensions of this matrix? Good. 4 by 5. 4 rows, 5 columns.
Now, if your decimal like goes into the hundreds or something, will it actually?
It's not going to require that program.
If your decimal is like actually show on your matrix, cut it off.
Should show. Unless you have something set kind of strange. Well, it might, I don't know. It shouldn't. Does it round it? Did you get like negative 119 for the second one?
Cut it off.
Well, finish editing it, type it in, and then print it out. See if it prints out correctly. 68. Yeah. You're not still running the program, are you? Oh, no. Don't exit the program to enter this.
I did to enter it.
Oh, we're not going to use the program for this one.
Okay. So what do we do?
I'm waiting for everyone to enter in the matrix. So right now it's still paused. Yeah. You know, it occurs to me I might need, in this situation, something that I haven't felt the need for before. Are you guys almost done with this? Do we got this entered in? There's a couple people that don't have it in yet. Ronnie? So after you enter it in, hit the second key, then the matrix key, and print it out. Make sure that it looks like it's supposed to. Now we're going to take a look at this in a couple different forms. One of them is Row-Echelon Form. Now here's the thing. I don't know exactly how I'm going to test you on these things, but I do, at some point, want you to show me that you know how to do the work. But I have no problem telling you how to find the answers and check your answers. That's fine with me. You should be able to get these problems 100% right. I'm telling you exactly how to get the right answers. So, hit the second key, then the matrix key. Go over to the math menu, and then go up. Use the up arrow, and you should see reduced echelon form. That's A. select A. We want A for whatever matrix you just typed in. So go back to your matrix menu, hit second, X inverse, and select that matrix. And that should be able to give you the row echelon form of that matrix. Now you might look at it and go, oh, God, it looks so awful. But has everyone at least got this much? So far, so good? Let's make that look a little prettier. Do you think it should look a little prettier? Let's make it look a little prettier. Hit the math key, and the first option there turns your answers to fractions. So press enter twice, and oh, still looks ugly, but it doesn't look as bad. Yeah, it still looks intimidating. But the nice thing is you can see some of the values here, right? For instance, Z is negative 3.2. Actually, that'd be W. Z would be negative 1.2. W would be negative 3.2. And then you could solve by back substitution to get these other ones. So that's your row echelon form of this matrix. Let's go a little bit better, right? Let's make our calculator do all the work. Ready for that? What would be making our calculator do all the work? Does anyone suggest? Reduce row echelon form. So go back to your matrix menu. Second matrix. Over to math. This time we want reduced row echelon form. Oh, there it is. Selection B. So reduce row echelon form. Second matrix. B. Bam. There you go. Nice. So those are your answers right there, right? That's it. You know you can get this problem right. So the question is, are you going to take the time to do that on test? And the answer is, I hope so. So.
We can solve most of the 4, right? Using that?
What's that?
We can use, how 4, 10.1, 10.2 we were solving?
Yeah, you can use the addition method and substitution method, to solve it. But once you start getting beyond 2x2 and 3x3 systems equations, it gets really tedious to solve these things by hand. So that's why we're starting to bridge the gap and to move towards solving it on a calculator. Okay, and that's exactly what we're doing with this kind of stuff. Now we saw earlier that things can go wrong when you're dealing with a system of equations. For instance, problem number 16. Problem 16, we said, oh, well, gee, that's inconsistent. There's more that can go a little bit astray when you're working with systems of equations. Let's see. Let's take a look at problem number 46. Now, I'm not going to take the time for us to put this into our calculators, etc., and do reduced row echelon form. But here's problem 46. If I did my notes correctly, then the reduced row echelon form of this would look like this. For our F of number 46, would be something like this. 1, 0, negative 1, 0, 0, 1, 0, 5, 0, 0, 0, 0. Yes. The only difference is that the calculator is doing all the adding stuff like that, whereas when we did it, we were doing it kind of step by step. Yeah. So pressing these keys makes this happen really quickly. Except there's a problem here with problem 46. Can you see it? Yeah, the 0, 0, 0. Does that mean it's inconsistent? No, because really this says 0 equals 0, which is true. So we're okay there. But let's see what else it says. I've got x minus z equals 0, and y equals 5, And what's this last equation say? 0 equals 0. So really it's not telling me anything about z. Z can be anything. Now let's just say z is z. I'm not going to try and give it a new name. But if that's true, then I can say, all right, well, that's really x equals z, y equals 5, and z equals z. In other words, I've got a solution that can be written like this: z, 5, and z. This is a generalized solution. When you pick the value of z, then you get a specific solution. If you want to pick z equals, I said z equals z here, my bad. If you pick z equals 3, then your solution is 3, 5, and 3. If you pick z equals negative pi, 5, and pi. But z can be anything. And what's going on with a solution like this is that your three planes are intersecting along a line. And you're giving a parameterized version of that line as your solution. Let's try a different one, kind of like that, and building on this a little bit. Well, there are an infinite number of solutions because you pick your value of z, and you can pick z to be anything. You can pick z. No, I wouldn't like that for this one. For this one, I want to see the parameterized version of your solution. I want to see something like this. And we're going to practice this again with a different example. And I thought this was problem number 42, but it didn't work out that way in my book or when I did it earlier. So let's just go with this example. You've got a reduced row-echelon form of your system equation. It turns out to be this: 1, 0, 4, 10, 0, 1, negative 1/2, and 7/2, and then 0, 0, 0, 0. So kind of like our last one, let's write down what these equations are saying. The first one says x plus 4z equals 10. What's the second equation saying? Thank you. Y minus 1/2 z equals 7/2. And the last one's not going against anything, right? So that's where we're just going to say, all right, well, let's let z equal z. And then everything here can be written in terms of z. So if I move the 4z to the other side, I get x equals negative 4z plus 10. Y equals 1/2 z plus 7/2. And finally, z equals z. But everything is defined in terms of z. Negative 4z plus 10, 1/2 z plus 7/2, and z. So once you pick a value for z, you get your values for x and y. Just kind of a heads up, the book is going to use t where I use a z. I don't know, I kind of looked at this and I thought that z might be more friendly for you. Use whatever you're comfortable with. If you want to put a t here, you get 1/2 t plus 7/2, negative 4t plus 10. So you can write this all with t's as opposed to z's. Any thoughts on this last example of a dependent system of equations? So you got an infinite number of solutions because you're two, really you've got two planes effectively, and they meet at a line. For homework, try 13 through 17, 21 through 25, 29 through 45, 65, 67, and 71.